frequency. Next we are going to discuss about the concentrating collectors. So two types of collectors which is used to convert the solar energy into heat energy. One is nothing but flat plate collector, another one is a concentrating collectors. So concentrating collector, in the sense we are using a reflector. So here it is a reflector, parabolic dish is used. So the reflector to concentrate the sunlight on the absorber of the solar collector. The size of the absorber is dramatically it is reduced, and it also which reduces the heat losses and increases the heat efficiency. We are using this kind of parabolic reflector. So what happened, in the sense the sun energy will be collected in all the areas of this space, and there is a center part, we call it as absorbing surface, where the sun energy will be reflected back and focal to the particular point, where this point the total energy will be collected by the solar collector. That is nothing but concentrating collector. Normally we are using for the solar tracking solar tracking system, this kind of parabolic Stirling collectors are used. Another advantage is, in the sense, which reduces the heat losses and increases the efficiency at high temperature. And one more thing is the cost. When compared to the other kind of flat materials, the reflector cost is very less than per unit area. If you talk about the solar cell and those things and all, unit area cost is very high, but even in flat plate also it is very high. But here in parabolic reflector, the unit area cost less per unit area than the other collectors. This class of collectors is used for high temperature application. Flat plate collectors are used for the low temperature applications, and this concentrating collectors are used for the high temperature applications, such as steam production for the generation of electricity and thermal detoxification process. There and all, this kind of concentrating collectors are used. These collectors are best suited for the climates that have abundance of clear sky. If the sky is very clear, then this is the best collector. This is the best collector in order to generate more temperature. More electricity can be produced with the help of these concentrating collectors, or more thermal heat energy will be consumed by this collector if the sky is very clear, no raining, no cloudy, in the sense, then this is a very good collector called as a concentrating collector. There are two types of the collectors. One is a stationary concentrating collector, another one is a tracking concentrating collectors. So stationary concentrating collectors, in the sense, it may be have liquid based collector, or it may be air based collector, or it may be a oven based collector for the solar cookers. Parabolic dish collectors are used for the solar cooking process. And another one is called as tracking collectors, tracking concentration collectors. So tracking concentration collectors, in the sense, it will track the sun. It will that parabolic reflector is nothing but parabolic dish is rotating in nature. It will track the sun according to the sunlight can be gathered, and the energy will be converted into heat energy. That is nothing but the tracking concentration collectors. So stationary concentrating collectors are operated in stationary mode, that means fixed mode. So it is a fixed mode collectors. What kind of application we can use, in the sense, air conditioning process, room space heating process, and all these concentrating collectors are used. So these concentrating collectors use compound parabolic reflectors, and flat reflectors also can sometimes it may be used for directing the solar energy to the absorber or to the aperture. So how much acceptance angle for the particular collector is decides the how much energy can be converted into thermal energy. So wide acceptance angles, in the sense, which eliminates the need for the sun tracking system. If it is a smaller parabolic dish, in the sense, then we have to go for tracking concentrating. If it's a larger parabolic dish, in the sense, no need to track it. So the entire energy will be obtained. So sometimes this class of collector includes parabolic flat plate collectors, flat plate collectors with the parabolic boosting reflectors, and solar cooker are also used for this applications. And previously I said that no tracking concentrating collectors is like a wherever high temperature is required, this kind of collectors are used as a solar electric generation tracking. And here the sun is very necessary, so heliostatic process is a very good example for the tracking of mirrors and reflect the solar energy into the fixed target, that is in the tallest, the receiver is kept in the tallest tower, so the sun energy will be tracked and that will be converted into heat energy, or it may be that heat energy is converted into mechanical energy, and mechanical energy is converted into light energy or electrical energy. Electricity will be produced. So where this concentrating collectors are used, in the sense wherever high temperature is required, more than 100 degrees Celsius to 1200 degrees Celsius or 1400 degrees Celsius, in the sense there we can use this one. Next one is comparison of the collectors. So while talking about the comparison of collectors, two important parameters we have to keep it in the mind to compare any kind of solar collectors. One is how much temperature range required for the various range, and collector concentration ratio, and temperature range required for the various application for the particular range. So the two things we have to keep it in your mind for the comparison of the collectors and while designing the collectors also. So collector is nothing but it is defined as the concentrating collector if the absorber area is smaller than the aperture area. That means the collector, its absorber area is smaller than the aperture area. Then if reflective surfaces are used to reflect the portion of the incident sunlight into the absorber, okay, that is we call it as collector concentration ratio. Collector concentration ratio is nothing but the ratio of aperture area to the absorber area. Aperture area to the absorber area, we call it as a collector concentration ratio, CCR. Okay, it is also used to measure for classifying the collectors. Various collectors can be classified by using the CCR. The ratio approximately determines operating temperature. Method of classification by using the operating temperature range of the various collectors. And concentrating collectors with the low concentration ratio. Suppose the CCR is less than 5, greater than 2 or less than 2, in the sense this absorber, the absorber which is used in that collector, which interrupts only the major portion of the incident sunlight, and not only at fixed altitude and various altitude of the sun angle can be obtained if the CCR ratio is less than 5. So acceptance range is as wide as 40 to 60 degree can be, the energy can be received from the solar energy or sun. Okay, such collectors can be operated in the stationary mode, and tracking sun is not required if it is generating more high temperature, and the collector that should have the high concentration ratio, that is CCR is greater than 10, in the sense high amount of temperature can be generated by using this technology. Next we'll compare the various collectors in the parameters like what kind of collector we are using, what is the absorption type we are using, concentration ratio, indication, temperature range, application, and some figures also there. Okay, first is a stationary concentrating collector, and then we are talking about the single axis tracking collector and two axis tracking collectors. So motion, according to the motion, the collectors are classified in three ways. One is stationary collector, single axis tracking collector, and double axis acting collector. Okay, double axis tracking collectors. According to the collector type, in the sense we can classify that a flat plate collector, evacuated tube collector, and compound parabolic collector, and linear Fresnel reflector, and parabolic trough collector, cylindrical trough collector, parabolic dish reflector, heliostat field collectors. So according to the collector type also we can classify. According to the motion we can classify three types. In that first one is a stationary type. Stationary type in the sense there are three collector types are there. One is a flat plate collector, another one is evacuated collector, and third one is a compound parabolic collectors. So absorber type, how the absorbers are designed in the sense it is a flat in nature, and the concentration ratio is 1, CCR is 1, and the indicative temperature is nothing but 30 degree to 80 degree Celsius. The application is nothing but space heating, space cooling, water heating, and low temperature applications where we can use. This is nothing but it is a flat plate collector. This is a flat plate air collector, and this is flat plate liquid collector. Next one is a evacuated tube collector, ETC. It is also flat type absorber, and concentration ratio is 1, and the temperature ranges is nothing but 50 to 200 degrees Celsius, and the same application, space heating, cooling, water heating applications we can use, and this is it's a parabolic in nature. And next one is nothing but the compound parabolic collector. It is a tubular in nature. The ratio is 1 to 5, and the temperature, operating temperature is 60 degree to 240 degree Celsius will be obtained, and applications are high temperature applications and air conditioning process. This is nothing but the compound parabolic collector. Next one is single axis tracking collector. There are three types of single axis tracking collector. One is nothing but a linear Fresnel reflector, parabolic trough collector, and cylindrical trough collector. So linear collector, Fresnel collector uses the absorber as a tubular, and the CCR ratio is 10 to 40, and that operating temperature is 60 degrees to 250 degrees Celsius will be obtained, and which is used for the high power application, high temperature applications. This is nothing but the linear Fresnel reflector. Second one is parabolic trough collector. It is also called as PTC. It is also in tubular nature absorber. 15 to 45 is the CCR, collector concentration ratio, and the operating temperature is 300 degrees Celsius, and this is application is high temperature applications. Cylindrical trough collectors, it is also tubular in nature absorber, 10 to 50 CCR ratio, and 60 to 300 degrees Celsius is the temperature which is obtained. This is nothing but the cylindrical, the chamber is in the cylindrical in nature. And the next one is a 2-axis tracking system. So here two types are there. One is a parabolic dish reflector, another one is a heliostat field collector. So HFC and PTC, and the absorber is a point. So heliostatic in the sense, in the top of the tower one point will be there. So whatever the reflectors which is kept in the area, that will be reflected to the particular point. Parabolic in the sense it is like a dish type. There also the sun rays are falls onto the dish, but it will be reflected back to the one particular point. And what is a CCR is nothing but 100 to 1000 or 1500 ratio, and the operating temperature for the parabolic trough collector is 500 degree heat will be generated, and heliostat in the sense 2000 degree Celsius heat will be generated. It is also used for the high power applications.